Okay, so what I want to do in this video is I want to go over managed code a little bit more than we already have. We talked about it in sort of a conceptual way and what it is and why it's important to us when we deal with applications that are written in managed frameworks such as .NET and Mono, which are really sort of the same thing, if you will. For our purposes, they are the same thing. There are some subtle differences, but we're not going to worry about that. So we're going to start the game. New game. Launch campaign. We've constantly been going to random. So let's select something else. We'll go to Mage. Yep. Spend some points. I don't know. We'll do that as well. We'll get rid of that. We'll get rid of that. Bring it back to 5. Okay. We'll minimize it. Bring up the cheat table or the cheat table that we are working on. Attach cheat engine to the process. Say, yep, we will enable our script. Go back to the game. So the way we left it is that when we click plus, it'll go to 100. And when we click minus, it'll go to 15. Click plus, it goes to 100. Click minus, it goes to 15. Click plus, it goes to 100. Click plus again. Click plus again. Click plus again. Again. Stays at 100. For argument or for demonstration purposes, we will click minus a bunch of times. It goes to 15. Stays at 15. So we're good to go in that respect. So how are we demonstrating managed code? Because if you noticed when we came into this menu, what I did was I spent a point here, and then I spent a point here. And then I immediately got rid of those points, brought it back to 5, minimized it, and fired up cheat engine and our table. That was a totally contrived thing, because I knew that if we just started up the game and didn't actually spend or remove a point, you would never be able to find, or ALB scan would never return any results. Now, why is that? It's because the game only loads as much as it has to into memory. That's what we're going to say. That's sort of our working thesis, if you will. So when you click plus for the very first time, say, we'll back out here. Let's say that you just started up Shadowrun. You have not clicked on anything yet. The actual assembly instructions the assembly instructions that tell the game what to do when you click on plus in the new character creation screen are not in memory, along with any other function or instruction that it has not actually been required to be in memory yet. This is what we mean when we say manage code. So we have new game, launch campaign. Yep. Yahtzee. So plus, minus, everything's working. Our script is loading. So let's disable the script. Let's back out again. Go back to new game, launch campaign. Do that. Yep. We're not going to click plus. We're not going to click minus. We're not going to do anything. We're just going to come out here and enable the script and see if the script works. It does. It enables itself. So AOB scan says, I have found results. I know what I'm doing. Or you are telling me that you know what you are doing. I have found byte arrays, and that's it. So plus is going to be 100, and minus is going to be 15. There you go. So what are we talking about? Well, the reason that this is working is because we have previously gone in and actually clicked plus or minus. So now the instructions that we are looking for with AOB scan exist in memory. It doesn't matter how many times you restart the game or load a save game or whatever, those instructions are always going to be in memory because you've already used them. What managed code means on a practical level is that the instructions will not be in memory until you've actually used them. We have already used them, so it's sort of menu agnostic, if you will. It doesn't matter where you are in the game, how you or what you're doing, as long as you have forced those instructions into memory by triggering some event that requires those instructions. They will always be there after that point. Maybe not always, but we're going to operate under that assumption. So how can we prove this? That we're not making this up. It's really easy. We're going to close the game. We're going to close cheat engine. We didn't have to close cheat engine, but we're just going to. So now we're going to restart the game. So memory's wiped. Everything is clean. We'll go to new game. We'll go to launch campaign. We'll do, I don't know, female, human, rig, or continue. Yep. So now we're going to go down here. We're going to open up our cheat table. We'll attach it to the process. Yep. All right. We'll go back in the game here. I want to be absolutely clear. We have not clicked plus. We have not clicked minus. Obviously, you can't reduce your karma any lower than sort of the fixed values that it gives you. Have not clicked anything. So by not having clicked plus or minus, by association, we are putting forth the idea that the instructions for clicking for the instructions that are executed by this application when we click plus do not exist in memory. Now, how can we prove that relative to what we were saying? It's really easy. As we have talked about, we'll open up the script here. What is AOB scan? AOB is scanning for bytes, or an array of bytes, or just bytes is sort of the general blanket term. What are bytes in the context of AOB scan? They're assembly instructions. We've talked about this and really sort of beat it to death. So we know that this is a series of bytes right here, but what it really is it's a series of instructions. As it turns out, this is one instruction, and this is the second one. I just, I don't know, I just sort of, again, if you're watching the series in sequential order, then you'll be familiar with this. So when we click enable script, or we tell cheat engine to enable the script, however we want to do it, it will search for this array of bytes and it'll search for that array of bytes. And what it's really doing is it's searching for assembly instructions, because assembly instructions are essentially reduced down to just byte patterns, and on a very lower level, they're reduced down to bit patterns. So let's open up Cam Studio here, make sure we got the time. We do. So let's try and enable our script. And as we talked about earlier, if AOB scan fails, if you have a script and AOB scan is in that script and it fails, your script will never assemble, execute, load, do anything. That's not specific to one AOB scan. If you have 10 AOB scans in one script, which is not entirely uncommon, and one of them fails, then your script will never enable. So let's see if we can enable the script. So we're going to go over here. We're going to click active and see what we get. It's probably done by now. Let's double click here. It is done. We get nothing. The script dumps. Hard exit. We'll do it again. I just clicked it. There's some lag. It's scanning. Do it again. There you go. Done. We'll click plus. We'll click minus. Go back here. Enable it. Try and enable it. There you go. There's an X. What the hell's going on? What the hell that is going on is that the instructions, the assembly instructions, and therefore the byte patterns or the byte arrays that are associated with those assembly instructions, or that make up those assembly instructions, were not in memory until you clicked plus and until you clicked minus. So now that we have clicked plus once and we have clicked minus once, now suddenly our AOB scan and our script is like, oh yeah, no, I found that byte pattern, no problem. That's it. So again, let's we will walk through this one more time, because this is very important when you're dealing with .NET or mono games. This is what is going to absolutely melt your face, to use a sort of a gaming thing. We'll disable it here real quick. So let's shut the game down, shut cheat engine down. Again, manage code is a bitch when you are doing some of this stuff. It is awesome from a development standpoint, because you get all these benefits and well, you get some benefits and some penalties, but most people think it's worth it. But when you are coming at managed code from the avenue of cheat engine and trying to hack a game, it sucks ass. So let's start the game. Now, in this, people will be like, oh, it doesn't look that hard. It is hard. I am really dumbing this down a little bit because I know that this game runs on mono and I have set this up in a contrived way so that we can demonstrate this. But if you have no idea whether a game is managed or not, and even if you do, whether it's, say you do know that it's managed, there will just be some times where you'll just forget to, force certain routines in memory, and it's just one more thing you have to worry about, and it just becomes a real pain in the butt. So that's kind of why I'm sort of spending a whole video on this topic. So let's go to new game, launch campaign. I don't care. We'll do that. Do an orc. Do a physical adept. An orc adept sounds dangerous. So we have not clicked plus. We have not clicked minus. We have done nothing. We will minimize the game. We will open up our cheat table. We will attach cheat engine to the process. We will open it. We will keep the code list. We will go back here. We will go back here. Let's try and enable our script. What is our script doing? As we have talked about and talked about and talked about and talked about even more, is it is searching for this array of bytes. This array of bytes represents some series of assembly instructions. Instead of actually having to say, AOB scan, AOB spend point, comma, and then actually type out the assembly instructions, what you're really doing is you're saying, here are the bytes or the bit pattern that represent the assembly instructions that I am looking for. And AOB scan says fine, and it sort of goes out into the memory of the process and it finds them, or at least it tries to. And if one AOB scan in your script fails, your script will never enable. So let's make that point. We will go to active. We will click it. It will try to enable. It will hang for a couple seconds. It will do nothing. It will not enable. It will bring this up because I double clicked here. So I know that cheat engine has unfrozen itself. Close it. Let's try it again. Peanut gallery. Double click Loftware again, or the description. When the description pops up, I know cheat engine has no longer done scanning memory. So what's going on? As we talked about, what's going on is that the instruction for increasing, decreasing this available karma value during character creation is not in memory. They do not exist yet. They have not been forced to be evaluated, loaded, executed, whatever you want to say. We're not drawing any distinction at this point between those terms. So let's click plus. There we go. Oh, well, we just forced those instructions to be in memory. No, we did not, because our script is in two parts, spend point and decrease point. So let's see if we can enable it now. We might be able to. It's possible. Doesn't look like it. No, nothing. So what do we do? Spend another point. There we go. Well, certainly it's in memory now. No, it's not. So we'll do that. We'll double click here so we know when it's unfrozen. Doesn't always work, but it's just sort of something that I do. No, it's not working. So let's subtract 1 point. So, again, we'll just beat this to death. We're running out of time, but, why is this not working? Because we've only loaded the instruction for the first part, for spending a point. We're only loading the assembly of spend point into memory. Decrease point, we still haven't clicked minus, so those routines or instructions are not in memory. So we'll click minus, go back, try and enable script again. It's going to work. There you go. It enables +1. It's 100. It's 102. That's unfortunate. Looks like we have a bug. If I had to guess right now, it's probably because when we were originally screwing around with it, and we were like, well, there's two values for decreased karma and that instruction in memory. We're like, well, this may come back and bite us in the ass. That's exactly what's happening right here. This is coming back to bite us in the ass, but anyway, we'll deal with that in the next video or two, however long it takes us. But at this point, you can see that you cannot find the instruction for modifying, or the instructions for modifying this value in memory until you've actually forced them into memory. How do you force them into memory? You simply trigger some event in the game that forces it to modify this value. It's spend a point, the value is changed, reduce, the value is changed, and that's it. So manage code, be very, very careful when you're dealing with it.